Good evening. How are we doing today? All right. Can you hear me all right?
Good.
Yes.
Yes, we see.
Yeah.
Yes. Thank you. Thank you. Well, a couple of things before we get started for today's lesson, okay? Uh, Number one is we have problem set 3 due today, right? And then today's lesson we will go over lesson 4. And next week, September 24, we will have a quiz. And we will have a quiz. The content area is covered from lesson 1 to lesson 3. Like a problem set 1 to problem set 3. So we will not have a meeting next week. We only have a quiz, okay? We only have a quiz, but we don't have a meeting next time. And you will do the test just like you did the post test. So you will complete the post test by next Wednesday. So I would open it up, the quiz like a Wednesday morning, and you complete, by 11:59 by Wednesday. Is that clear to you?
Yes.
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 So next week we don't have a meeting, just only test, okay? So you will complete the test, okay? Just like we did for post test. So everybody doing kind of very well for the post test. You're familiar with the D2L. So you will find a test from the assignment, just like you did for the post test.
Just like you did for the post test,
right?
Right.
All right. So if you have any questions regarding the methods you want to learn more, and I think so, right after class, I would have like an office call for you, okay? So today we're gonna move on to lesson 4, okay? Lesson 4. And Nikki, could you please just mute, please? Yeah, thank you. So we're moving to lesson 4, division of a whole number. So last time we talked about multiplication of whole number. And this time we're gonna talk about division of a whole number. A divided by B equals C. So therefore, we have a name for A. What does A mean? A means the name is a dividend. And B is a divisor. And then C is called the quotient. Okay. Now here's a definition for the division in whole number. And let A and B be whole number, and with a B not equal 0. Then A divided by B equals C if only if A equal B times C for unique whole number C, okay? That is the definition, okay? So why B is not equal 0? Can anybody tell me why? Why this is not equal 0? Cannot be equal to 0. Can anybody answer this?
Is 0 not a whole number?
0 is not whole number, and what else? If b is equal 0, then what happens?
It can't be the divisor. You can't divide a whole number by 0.
And that means undefined. Yes, we cannot divide.
Right.
Yeah, we cannot divide it by 0, right? And that means if you want to, let's say you want to tell the children, I say, I have $10. I share nobody, share $0 to, and then that does not make any sense. Then why you have to share, right? So I mean, b cannot be 0. That means undefined. So and 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 let's say we have a is equal 6 and b equal 3. So we take a 6 divided by 3 equal 2. All right. So now we can say 6 is also equal 3 times 2. All right. So that's a division and multiplication. You know, you make a connection with division and multiplication. Okay. And next, we have a division of whole number. We have different models represent the division. The first one is called a repeated subtraction model of a division. Okay. So here is a word problem. There are a total of 28 apples. If I give 4 apples to each person, how many people will receive the apple? So therefore, we can do. Let me see. We have it. Yes, we can do repeated subtraction. Okay, so we want to do 28 subtract 4, and then I got a 24. I want to repeat again. Repeat subtraction, and then that will be 20. Then I will take a 20 subtract 4, and I will get 16. I take a 16 repeat subtraction. So I got the 12. Next 12 subtract 4, got 8. Next 8 subtract 4, got a 4. The next 4 subtract 4, oh, got 0. So I repeat subtraction for how many times? That's the 1, 2, 3, 4, 5, 6, oh, 7. So the 7 means repeat is we subtract 7 times. So 28 divided by 4 equal 7. All right. So we repeated the subtraction. Okay, repeated subtraction. That is one meaning for this, right? And the other one we call the partition model of a division. Okay, there are total of 28 apples. If I share the apple among 4 people, and each person receive the same number of apples, how many apples will each person receive? Okay, so here, this partition model, I take a 28 and divide it by 4. And I got a 7. All right. And what does this mean? I'm going to change the color. Here we have a 28 apples. All right. So we want to what's the partition model meaning? Okay. And then 4 and share, divide here, we can say share. All right. And then 4, that means 4 people. All right. And then 7, okay. What does the meaning for 7? because you have 28 apple, everyone I will share. We want to share 4 apple. Everyone can get the 7 apple. So that is the partition model of a division. Okay. And another model, we often use in the word problem is like this. We call the missing factor model of a division. Missing factor model of division. For example, you have a rectangular basket and want to store 20 apple in it. If the basket can only fit 7 apples in each row, how many rows of apple will be in the basket? Okay, so we will use this missing factor. Okay, missing factor. So we have 28 divided by 7. So what's the missing factor? That means a box. All right, or we want to say X. So therefore, if we wanna, we also can say the 7 times a box, which is equal 28, right? So that is another way we wanna, and another model we can tell the story for children. Okay. All right, and then next, we have several algorithms for whole number division. And last time, remember when we did the 50 items review computational test, and we did the long division, scale for algorithm, and we did a short division, but we didn't do accessible division, right? So today we're gonna go over with the accessible division. All right. Now, first of all, is a long division. Let's say I want to take a 95 divided by 5. All right. So long division, we have to write a lot of things, right? So normally children are struggle with, so what's the first number here we have to fill in, right? So long division again is also called the English method, right? So you want to take a 5 times 1 equal 5. And you want to subtract this. 9 minus 5 equal 4. And you 5, bring it down there. And then you take a 9 times 5 and 45. All right. And it's important, if you have a arrow sign like this, and that helps children to see what's the place value code. All right. And next example, 295 divided by 5. 2 is not divisible by 5, but we're going to move next place value. So therefore 29, okay, we take a 29. So take a 29, so therefore what's the number is close to 29? So therefore 5 would be, times 5 would be 25, would be close to 29. So you subtract 29, 25, you got a 4 for this. And then 5, you bring it down 5 right there. So we have a 5 times a 9 equal 45. Subtract this, we got a 0. All right, so long division, okay? I think the long division, most of people do not have question for this because most of you learn the way from the school this way, right? And
Yes.
but the disadvantage for this method is, sometimes you will say 1, and then children will think of that this is 1. Actually, it's not 1, right? But this is only for the algorithm. It's more like, help us to do the calculation. But actually, it's 10, right? So that's why we have another one called a scaffold method. the scaffold method, I like the scaffold method is more clearly place value compared to the long division, okay? So for instance, scaffold method, $95 and 5. Okay, change the color here. So 5, 95 divided by 5. So here, I take a 10, 5 times 10. So I got a 50. So 95 subtracted 50, I got a 45. And next, I take a 9, which is a 45. So edit the number quotient on the top. So we take a 10 plus 9, which is 19. Does it make sense to you for this one?
Yes.
Yes.
Can you do another one for this one? I want you to give you a minute and try this one, okay? $295 divided by 5, okay? Take a minute, try the scaffold method. Okay, are we done?
No, I got confused because it's a 3-digit number now. So I don't know where to put the, no, I'm confused on this one.
Can we start? Let me change the color here. All right.
Megan.
Can we start here with times of 50, yes or no?
Oh, yes. You should.
So I
Right?
have
Yeah,
a 250. Is that right? But
right.
here, actually, the long division does not tell you the place value, just tell, oh, 5 times 5, right? You
Mhm.
can compare. Here is much clearer with the place value. You take 5 times 50, you got 25, right?
Mhm.
And you want to subtract this, and
It's
then you
59.
want to got a 45, right? And next, you take a 9 times 5, 45. You subtract this, yes. And then add it up the total on the top. So 50 plus 9, so the answer will be 59. Our answer will be 59. Is the same answer as what we did for this one, yes or no?
Yes.
Mm-hmm.
Mhm.
All right. And then here, scaffold method is more like a focus on more place, place value.
Mhm.
Now, here is another question for scaffold method. I think the scaffold method, it is more flexible, okay? Let's say, yeah, I want to do 50 here. Yes, okay. What about if I want to do start with a 40? And then I got a 200.
Mhm.
And I got a 95. 295 minus the 200, I got 95, right?
Mhm.
And the next one, I will just take a 10. And then I got a 50, 45. And the next one, we got a 5. 5 times 5, 5 times 9. Sorry, 9. It's a 45.
Mhm.
So the answer is 10 plus 40 plus 10 plus 9. I still get a 59. Is the same answer as this one? Yes or no?
Yes.
Yeah. It's more flexible. I mean, as long as yeah, because this one is more focused on more place value, so we still can get same answer like a like a long division, right?
Mhm. So can I ask you, does it matter which number we start to multiply it with, no matter what the question is? So like, can I do, 30? It doesn't matter which one, it's just gonna be a longer scaffold?
Yeah, I think so. You have a more flexible if you can start with. Let's say you want to start with a 30.
Mhm.
Yeah, 5 times 30, 150. Yes, you can do this as
Yeah.
well,
Okay.
It just
right?
eliminates the guess game in the beginning when you're thinking how many times can this go into this, because then if you realize there's more left, you just build your scaffold higher.
Right.
Yeah. Yeah,
That's
yeah,
what
but
I'm trying to
it's
figure
better
out.
to do it, just like this. You close the number is 250, 290, and then it's better to do it. But actually, the idea for scaffold method is just like a more focus on the place value instead of like this. You don't focus on any place value at all. Does it make sense to you?
Yes.
All right.
Mhm. Thank you.
Can you try another problem?
Mhm.
704 divided by 4. Okay, take a minute to do this.
Mhm.
All right, are we done?
Mm.
All right. Let's say I want to start with 100. So that would be 400. Subtract this. 704 subtract 400. I get the 304. Then next, I would take 50. 4 times 50 got 200. Subtract this. 104. Next, I would do 20, and therefore I would get 80. Subtract this, I got the 24. What about 624? And I add together for this. So 100 plus 50 plus 20 plus 6, 176. Did you get 176, yes or no?
Yes.
No.
All right. See, we have alternative way of doing division because we help children to do the division, more confident. Because sometimes if we always focus on long division, children have a problem with what's the first number I have to fill in, right? Long division, you have no choice. If it hits 5, it has to be 5. If it's 7, has to be 7. It's not flexible at all, right? But scaffold method or accessible division, they have more flexible. They are not children will not struggle with what's the first number we have to fill in this. Are you with me for this?
I'm still struggling. What's the first number? You know?
Yeah, that's a long division. That is a disadvantage of a long division. Many children, they have problem with this. But what about if you try scaffold algorithm and you try the accessible division? They are happy to do division,
Mhm.
right?
Yeah.
You are struggle with the what's the first number to fill in, because here is a strictly rule. You need to find the, let's say, for example, like this one, you have to find, if the number is close to 295, and then you have to find a number is a can times it close to 295. That's why. That's why
Mhm.
children are struggling. Why not just try this one and this one, right? And actually, I really like the second one or third one, right? Now, here, the next one called accessible division. Have you ever heard about accessible division? Anybody? Have you ever heard
No.
about accessible
No.
division?
No.
Right. Well, I think so. Accessible division is more popular in 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 the recent textbook, because this will helping children better to doing division. Okay. Okay. Now let's give you an example for this. Okay. And personally, I think that I really like accessible division because it give you more flexible of doing division.
Mhm.
Well, again, before I want to tell you the accessible division, long division is also called English method. Some of European countries, they do not use a long division. They use accessible division. Right?
Mm.
So I think that they do not use the English method. They use a European country. They use this one, accessible division, a lot. And
Mhm.
I think that this is a good one to introduce children to do. Okay. So accessible division is like this. Okay. There is not strictly any number you wanna start with. It's very flexible. All right.
Mm.
It's very flexible. Unlike a long division, if you have to fill in one, that's one, two, two, and three, and three.
Mhm.
Here is more flexible. That's why, let's say I want to try 100.
Mhm.
I change the color. Okay. And let's say I want to do 100. Okay. 7 times 100, how many?
700.
700.
Mm.
And I will just subtract. 945 subtract 700, which is 2 for 245.
Mhm.
And next, I will just choose 30.
Mm.
7 times 30, how many?
210.
210, yes.
Mhm.
I want to subtract this. So
Mm.
therefore, I got 35. And I have 5 times 7, 35.
Mhm.
Oh, got a 0. And then added up the total here, 100 plus 30 plus 5. The answer 135.
Oh, that's easy. Thanks.
Now here, let's say, oh, I want to try a different one. Okay.
Mhm.
Let's say I wanna try. So the answer is 100. Okay. I want to start with. I'm not start with so 100. I'm start with 80. Still, if it still works.
Mhm.
7 times 80, how many?
60.
7 times 80, how many? So 560. Is that right?
60. Mhm.
So I want to subtract this. So I got a 385. So next, I take a 50. So 7 times 50, 350. Subtract this, and I still get 35. And then a 5. And then 35. And then 0. Added up the total. Oh, again, we still 135. Does that make sense to you?
Yeah.
How about if this makes sense to you? It's a so flexible. Okay. How about you want to try 70? Okay, go ahead and try 70. You want to try 70. You want to try 60. It's still working. I'll give you a minute to do this. You try 70. Start with a 70, still working. Okay, I'll give you a minute to try.
Mhm. 135. Okay.
Does it work for you?
Yes.
Yes.
17.
All right, so let's check your answers. It's all, if I have a 70, and then I have 7 times 70 for 90. And then I subtract this, and then I have 5, and then 4, if we 455, is that right?
Yes.
And I say I wanna, because I think 455, if I times 60, yes, it's more close to this number, right? And then I got the 420, subtract this, I still get 35 here. So therefore I have 5 times 7. 5 times 7 is a 35, is a 0. So added up the total, oh yeah, again, 135. Is that right?
Yes.
Right. Or if you wanna start, you wanna try here, not 60, you wanna try 50, still working.
That's what I did. 50.
Yeah.
That's what I did.
It's still,
Yeah.
yeah. Okay.
50
And then
like
you want to try, 10 again, right? So you got a 35 again. And then 5, 35. Oh, added up the total, you want a 135. Yeah. So you have more flexible, right?
Yes.
And children no longer struggle with what is the first number I have to fill in, right? I like it. So, I mean, if we have a better way of teaching children, why not? All right. Because sometimes if we only insist that teaching one way is not working, well, this is not good for children. It's not good for you, right? I mean, why not we have other methods and helping children to be succeed? Okay. And personally, I think I like this method. Okay, how about we try another way, another problem, okay? And this time, you have a freedom of choice, okay? 1,323 divided by 21, you have more freedom to using method, okay? To choose your the number you want. Okay, go ahead, try.
Mm.
I start with the 50. Maybe you cannot just, I start with the 50, but you can try different numbers. See if you got the answer. That's my answer. Okay, all done or we need a minute?
Need a minute.
Okay.
Yeah, I'm having trouble with this. Got it finally.
All right, good. All right. Let's check your answer. Did you get 63?
Yes, finally.
Yeah.
60.
Let's say I want to start with 50. So take a 50 times a 21. I got a 1,050. And I will subtract this. I will get have 273. And next, I take a 10. 10 times the 21, 210. Subtract this, I will get the 63. All right. Then I take a 3. 3 times the 21, 63. Got a 0. So therefore, added up the total for this, 63. Did you get 63 for this?
Yes, I got 63, but it took me a long time to get there.
Yeah. Or I want to have a 60, right? All right. Then we have, a second. Okay, and subtract this. And you got a 3. And you got a 3, 6. And then again here, 3 times the 21, 63. and then add together would be 63. Did you get this answer?
Yes.
Yeah.
Mhm.
So actually, there's more flexible of doing the method, and then if you have a freedom to choice of your, you don't want to struggle with, oh, what's the first number I have to fill in this, right? Yeah, and you have more flexible choice over here, right?
Mhm.
Good. And then I really like this method. And next is the short division. I think that we did the short division during our computational review. Still, do you still remember this one? Let's say we want to do 123 divided by 3, right? 123 divided by 3. And long division, you have to write a long number, right? But short division, you don't need that. You just write the answer, right? So 1 divided by 3, enough or not enough?
No.
What?
No.
Not enough. So therefore, move on to next place value. So therefore, 12 divided by 3, enough or not enough?
Enough.
Sure.
So therefore, 4, right? 3 times 4 is equal to 12, right? But short division actually is a 12 right here, right? And subtract this, you got 0. But we don't want to write this, right? We just will write the answer right away. Okay? The idea is like this. Okay, so that's the 12, and then 4, and next place value is 1. So the answer is 41. Does that make sense to you?
Yes.
Now, what
Yes.
about, I'm going to change this as 1, 2, 3, 4, and 5. Can you try it?
Yeah. Okay. That's fast.
Yeah, lightning fast, right?
Yes, very
Right.
fast.
See, again, the way I'm trying to introduce the method is just from the journal learner, everybody can do it, and then quick learner. So that's a quick learner they can do. That's a fast, lightning fast,
Yes.
right?
Mhm.
And you
Yeah.
guys are a college student, yes. So you
Yeah.
deserve a smarter way, right?
Yeah. Mhm. Thank you for that.
Yeah. So okay, again, 1, not enough. Move on next place value. That's a 4, and that's a 1, and that's a 1. So actually, the minus 3 is the remainder is 1, right? And remember that 1 we don't want to write here. We will write here.
Okay. Yeah.
Okay. So 15 divided by 3 and 5. 4, 1,
41.
1, 5.
Yeah.
Does that make sense to you?
Yes,
We don't
sir.
want to write here. We write a remainder right here. So we have 15 divided by 3, which is equal 5. So 4, 1, 1, 5. Did you get it right for this one?
Yes, sir.
All right. How about you try another problem? We okay. 295 divided by 5.
Mhm. Mhm. No. Okay.
Done? Oh wow, so quick. Uh-huh.
Yeah.
So 2, not enough. Move on next place value. That is a 5. Then 29, subtract 25, which is remainder is 4, right? So 4,
Mhm.
write down here. Did you write down 4 right here? So
Yes.
45 divided by 5, which is 9, 59. Did you get it right?
Yes, sir. Yeah.
All right, next problem. 945 divided by 7. Go down.
Mhm.
All right. So 9, okay. Let's see, change the color. 9, okay. So therefore 1. So 9 minus 7 is 2. So 24 divided by 7, put on the 3 there. So we have 24 minus 21 is remainder is 3. So put on the 3 there. 35 divided by 7, 5.
Five.
135.
Mhm.
That's the lightning fast.
Yes,
Right.
sir.
All right. So do you have any questions so far? Right. Anyway, but if you have more questions you want to ask me after this class, I will be here for office talk. Okay. So how about we take a 5-minute break? Okay, and then we will move on to divisibility rule. Take a 5-minute break. Okay.
Yes, sir. Thank you.
Yeah. All right, let's move on to divisibility rules. Divisibility rule 2. A number can be divided by 2 if the last digit is even. For instance, $24 divisible by 2, yes or no?
Yes.
Yeah.
Because the last digit is a 4. How about 128, yes or no?
Yes.
Yes.
Yeah.
Because the last digit is 8. Is it divisible by 2? 35, yes or no?
No.
No.
No. No, because the last digit is not even number, right? Divisibility rule for 3. A number can be divided by 3 if the sum of the digit is divisible by 3, right? So for instance, like 36, so sum of the digit is divisible by 3. So sum of digit. So we take a 3-digit, 6-digit, so therefore is a 9. So therefore, yes, this is divisible by 3. Does that make sense?
Yes.
How about 126? You want to tell me if this is divisible by 3, yes or no?
Yes.
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 So you have a 1 plus 2 plus 6, which is equal 9. Yes, 9 is divisible by 3. How about 112? Yes or no?
No.
No.
So you have a 1 plus 1 plus 2, which equal 4. Oh, 4, you cannot divide it by 3. So yes, this is no. Okay. Divisibility rule for 4. A number can be divided by 4 if the number made by the last 2 digits can be divided by 4. So for instance, 224. Is this divisible by 4, yes or no? Last
Yes.
2 digit. Last
No.
2 digit.
24 divided by 4.
Yeah, 24.
Yes.
Last 2 digit is divided by 4. So yes.
Yes. Mhm.
How about 536?
Yes.
Yes or no?
Yes.
Yeah, 36 is a yes,
Mhm.
right? How
Mhm.
about 525?
No.
No, because the last 2 digit is what? Is not divisible.
Mhm.
So no for this, right?
Mhm.
So that's the rule for 4. What about divisibility rule for 5? 5. A number can be divided by 5 if the last digit is a 5 or a 0.
Mhm.
So therefore, we have 215, yes or no?
Yes.
Yes.
Mhm.
Last digit is 5. Next one, 300, yes or no?
Yes.
Yes.
0 or 5, right? Yes. So therefore, yes. We're looking for the last digit, okay?
Mhm.
How about 423, yes or no?
No.
No. No.
No, because no. Okay, 3. 3 is not divisible by 5. It's not either 5 or 0, all right? Okay, so next one is a divisibility rule for 6. A number can be divided by 6 if it is divisible by 2 n divisible by 3. Okay, get this. N, not all, is n, all right? So let's say 36 is a 36 divisible by 6, yes or no?
This is yes,
Yes.
because it's 2 and 3. Yes, I go into 2 and 3. Mhm.
All right. What about 114? Yes or no?
Yes,
So is it divisible by 2?
No, it's by 2,
So-
but not by 3.
It's also divisible by 3.
Oh. 14 goes by 3.
Yeah.
Mhm.
Both can divisible, right?
Mm,
So therefore,
Okay.
yes, 6 is yes, right? And how we determine 3? 3 actually is to take a 1 plus 1 plus 4, which
Four,
is
yeah.
equal 6. Yeah, 6 is divisible by 3. So
That's
therefore,
right.
yes.
Three doesn't matter.
So
Okay,
114, yes.
Mhm.
114, yes.
yes, yes, okay.
How about next one? 225, yes or no?
124.
no, it's not divisible. It doesn't add up to 3. It's not divisible.
Very good. So it is divisible by 2, but 3 divisible by 3, yes or no? No, because
No.
2 plus 2 plus 4, which is equal 8. 8 is not, so no. So therefore, this number is not divisible by 6. Does that make sense to you? How to determine the number can divisible by 6, yes or no?
Yes.
Yes, now I
All
know.
right.
Mhm.
So we move on to next one, divisibility rule for 7. We have finished 2 and 3, 4, 5, 6, and 7. What is about 7? 7. To determine if a number is divisible by 7, take the last digit off the number, double it, and subtract the double number from the remaining number. If the result is evenly divisible by 7, for example, like 14, 7, 0, negative 7, etc., then the number is divisible by 7. This may need to be repeated several times. Okay? What does this mean? Here I have example.
God, that's so complicated. That's so long. Too many.
Yeah, yeah, that's how do we say the definition. But if I explain one, then you will understand what's going on, okay?
Okay.
Here is example. Three and 1,421. Okay. And now, wow, it's something, right? And I want to find out 1,421 is divisible by 7, yes or no? Okay.
Mhm.
Here we go. This is what we say. You want to take a last digit off. So take a last digit. Last digit is how many? Is 1, right?
Yes.
And we
Yes.
double it. Double it times 2.
Mhm.
Times 2. I put on
2.
here times 2.
Mm.
Take this number off and subtract. Okay. So
What's it?
1,401. We subtract this. We take 142 subtract 2. So therefore, we got 140. Are you with me for this step?
Yes.
But here we still the number is still big, 140. It's not easy for us to determine this is divisible by 7 or not, right? So therefore, I repeat it, do it, okay? So I take this number off times 2 again, double it again. Now double it again, put a number over there. just like this, we double this one, we take with this is 2, right? So we subtract this. 14 subtract 0, that is 14. Oh, so now we find 14. Is a 14 divisible by 7, yes or no?
Yes, yes.
Then therefore, this number 1,421 is divisible by 7. Are you with me for this?
No, I have a
Yes.
question.
Okay, yes.
When you
One more
double
time. One more
one,
time. One more time.
okay,
One more time. Okay. We want to determine 1,421 is divisible by 7. First of all, take a last digit off and double it. If we double it, we got a 2 right here. Are you with me?
Mhm.
that's
So
the
we wanna
question I
subtract
have.
it.
When you doubled the 1, why did it end up in the tens place?
No, it's different because not ended up tens place. It's different because this is how we determine. Okay, so that's why you say we take the last digit off and times. Okay, that's a rule.
Oh, okay. I see what you're saying. 1 times 2 is 20. Okay, so I see.
Not 20. This is different from our. This is different different from the place value. This is nothing to do with the place value. Okay. This is only determine how we find divisibility rule. Okay, that's a rule. Okay, so you take a 1, this number off, and times 2, got 2. Are you with me for this?
Yes.
So we have a 142 minus 2, we got a 40. But 140, the number is still big. We're not still not knowing is it divisible by 7 or not, right? So we have to continue repeat it. That's why we have to repeat it several times, right? Right. So we take this number, take this all number off, times this 2, and double it again. Double, I put it in here and subtract this. Oh, we got a 14. So therefore, 14 is divisible by 7. So therefore, 1,421 is divisible by 7. Can we do another problem?
Yes. So if you don't mind, I'm just gonna say something to my friends. So like he's saying you completely delete that last digit and you go out to
You delete the last digit.
you go to the digit before that.
Keep
and
going,
that's
repeating. Yes. All
you
right.
go off of the digit before
How about
that.
this one?
Just keep deleting. Okay.
Yeah, delete this number, but you want to take this number.
Double it first.
Yeah, a double. Yeah, you double it. Can take this number, delete this number, and double it. So that's why I have a 10, right? Subtract this. So we take 213 minus, we got a 203. But 203, we still cannot find it, right? So therefore, we're gonna delete this digit and we double it. So I double it, so therefore, which is equal 6.
Yes. And
So
then
subtract this. Yeah, I got a 14. Yes, I find 14. 14 is divisible by 7.
So it's divisible. This number is divisible.
Right? Okay. How about, can you try this one? Change the color here. Take this number 123, 1, 2, 3, 4, 5, 6. Okay, try it. See if this is divisible by 7 or not.
Mhm. Mhm.
All right. Let's
It's
work
not-
together, okay?
Mhm.
I want to determine 1, 2, 3, 4, 5, 6 divisible by 7 or not.
No.
So I take this number off, and then I double it. Double, which is 12. Are you with me for this step, yes or no?
Yes.
Then I do subtraction here. So we have 3 there, we have the 3 there, we have the 3 there, we have 2 there, we have 1, right?
Mhm.
But this number is still big. So I want to take this number off, and then I double it. Now I double it, I got a 6, is that right?
Yes. Mhm.
And I'll subtract this. I want to subtract this, I got a 7. And then because I regroup from here as a 2, so that'll be 2, and
That's
then
fine.
2 and 1, right? Can I still find it out 1, 2, 2,
Yeah, that's
7
where I messed up.
divisible
I
by
knew I messed
7?
up. Ugh.
No, so I have a double again, right? Take this number off, double again. So double this one, which is a 14. Are you with me for this step, yes or no?
Yes. Mhm.
So therefore, I take a 122, subtract a 14, I got 108, right?
Still not divisible.
Now 108, if I double it, that would be in 16, right?
Mhm.
That's too much. So why not just take a 108, try if it divisible by 7, that much easier. So 7, and then 38, and 5, 35. Oh, remainder is 3, so this is not divisible.
Mhm.
Are you with me for this one?
I knew it wasn't divisible, but I messed up 2 of the steps. Yeah.
Yeah.
Mhm. I calculated wrong, but that's right. Okay.
Okay, and then how? So that's the divisibility rule for 7. Okay. So this one is not divisible by 7, right?
Mhm.
Next, we're gonna do divisibility rule for 8. A number can be divided by 8 if the number made the last three digit will be divisible by 8. The last three digits. So 8, 1, 7, 6 divisible by 8, yes or no?
If the last 3 digits.
So we take the last three digit, right? We take last 3 digit to exam. Our last 3 digit, I will take our last 3 digit to exam divided by 8. Yes, 2 and 16. We move here down and then 6 right here, and then 2 and 16. Oh, yes, 22. So yes, this is a yes. All right. You use this last 3 digit to determine, right? What about 472? Is it divisible by, oh, no, 4,472? Is it divisible by 8? Yes or no?
Mhm.
So we take a last 3 digit, right? Try it. So take a last 3 digit, try it,
Yes.
and divide it by 8. And get a 5, 40, 72,
Mhm.
72. Yes. So yes for this. How about 3,566?
Mhm.
We take a last 3 digit and you try it, see if it is divisible by 8 or not.
No.
Now,
Mhm.
566 divided by 8,
Oh.
756, and then put a 0, 6 there. So therefore, no for this one. Okay. So divisible, the rule for 8, which is determined by last 3 digit, okay? If this is the last 3 digit divisible by 8, and then this number will be divisible by 8. Next one, divisibility rule of 9. A number can be divided by 9 if the sum of the digit is divisible by 9. So, for instance, like 198. Is 198 divisible by 9, yes or no? So we want to
Yes.
Yeah.
take a 1 plus 9 plus 8, this number sum, okay, it together, which is equal 18. Now 18 is divisible by 9, so therefore yes for this.
Mhm.
About 531. Yes or no?
Yes.
Yes, because
Yeah.
5 plus 3 plus 1, which is 5 plus 3 plus 1, which is equal 9. So 9 divisible by 9. So therefore 531, yes. About 204.
No.
204, 2 plus 0 plus 4, which is 6. So therefore, no. Okay. Next one, divisibility rule of 10. A number can divide it by 10 if the last digit is a 0. Okay. About 110, yes or no? Yes.
Yes.
About 120, yes or no? Yes.
Mhm.
About 133, yes or no? No. Because the last digit is not 0. Okay. Right? Easy. For 10 is easy. Now, the last one is divisibility rule for 11. Right. So this is a divisibility rule for 11. Take the digits from the right to left, alternately subtracting and adding. The original number is divisible by 11 if and only if the resulting number is divisible by 11. Oh, what does this mean? Let me give you an example, okay?
Right to left.
Actually, there's a 2 different way of doing this, okay? And I will show method 1. And then I will show method 2 for you, okay? And see which one you feel comfortable, okay? I mean, sometimes people like the first method 1, some people like a method 2, okay? Right? Let's say 121, okay? Is it divided by 11 or not? Right? So first of all, I take a 1, subtract 2.
Oh,
Okay. So you want to take this digit, subtract this digit, okay? So 1 minus 2, what you got?
Negative one.
It's negative 1, right?
Mhm.
So here, you will do subtract.
Mhm.
Next one, from here to there, you will do addition. So you take a negative one, since we have negative one, right? And plus one, and we got a 0. Is a 0 divisible by 11? Yes. So therefore, 121 is yes.
Mhm. Yes.
Let's try another one, okay? Let's try another problem. More problem, you get familiar with this. One 32. So first of all, I take a 2, subtract 3.
Mhm.
2, subtract 3, and I still get the negative 1 for this one, right? So I will
Mhm.
do subtract for this. It give you a mark for this. This is a subtract. And next, on this digit, jump to digit is not subtract, is addition, okay? So therefore, negative 1 plus 1. So I got a 0. Is a 0 divisible by 11, yes or no?
Yes.
Yes. So therefore, 132 is divisible by 11.
Mhm.
Can you try another one? Yep. 2035 is a 2035 divisible by 11. Take a minute, do this. Subtract, and next one will be addition. The next one will be a subtract.
And
The
you
next
alternate?
one will be addition.
Mhm. Yes.
Did you get a 0?
Yes, I did. Mhm.
Yeah, if you got 0, that means a divisible by
Okay.
11. Okay, so I take this one, subtract this one. So 5 minus 3, and I got 2, right? The next one is a 0, so I get a 2 plus 0, which is equal to, right? The next will be subtract. So 2 minus 3, 2 is equal to 0. So 0, yes. So the first one is a subtract, second one is a plus, and next one was subtract. So therefore, this is a 0. So therefore, this is a divisible by 11. Does that make sense to you for this one?
Yes.
All right. This is a method 1, okay? How about method 2? Method 2. Method 2 is like this. 1.1. All right. So we have our number, we have even, okay? So therefore, we do this one, is R even R, right? Okay. So therefore, we take R and R plus together, which is equal how many? Is equal
2.
to, and that is a 2, right?
Mhm.
And then finally, we take a 2 minus 2, which is equal to 0. So therefore, yes, 0 is divisible by 11.
Mhm.
So 121 is divisible by 11. Okay. Can we try another one? How about 132?
Mhm.
1 plus 2, which
Yes.
is equal to 3. Are you with me? And then 3, bringing down 3 right here, right?
Mhm.
So 3 minus 3, yes, 0. So therefore, this is divisible by 11.
Mhm.
I like a second method. What do you think?
Yeah. I think second
I-
method
I
is
like the
much
second
more.
I like a
method way
second
better.
method. I like a
Everybody.
second method. How about 2035? Okay, try it. Which one is faster? I like a second one.
Mhm. Yes, that's divisible. Yeah.
That's faster, right?
Yes, much more.
That's
Yeah.
much faster.
Mhm.
And upload for this one. Okay. And that's 0, 5 is a 5. 2 and plus 3 is a 3. Oh, 5 is a 5. So 5 minus 5. 0. So this number is divisible by 11. Is that right?
Yes.
Second method is better. How about
So if you have, I'm sorry, if you have a longer number, like the one you just did, you just alternate, right? You don't
yeah,
put it next to back to back. Okay.
yeah, I think so. That's why I use a color pencil. Does that help
Yes,
you?
yes. Yes, it does. Thank you.
That's why I use the color pencil.
Mhm.
Color pencil that helps you to see it. Right. Did you see this?
Mhm. Yes. Mhm.
See, color pencil strategy is very helpful because that's a show the visual representation.
Mhm.
So 7, 4, 0, I have 11 right here, right? And then 8 and 0 is a 8, right? So 11 minus 8, which is a 3. Is a 3 divisible by 11, yes or no?
Mhm.
Is a 3 divisible by 11, yes or no?
No,
No.
No. So therefore, no. This is not divisible by 11. I like the second method. Yeah.
Much
I don't
better.
know if you like the first one or second one, but I like the first one, second one. Okay. All right. So that's the problem for divisibility rule for 11. Okay. You can either use a method 1 or method 2. Okay. And then here is maybe that's a more problem like this. Okay. More it's a problem solving problem for this. Place a digit in the blank if possible that 5037 blank 8. The number is divisible by 11.
Mm.
How about I do one problem, you do one problem, okay?
Yep.
So, I don't know what's the number. I have to fill in this in order to make it divisible by 11. All right. So we can, let me see if I have space for this. Oh, right here. I do one problem, you do one, okay? will come here. 5, 4, 3, 7, and blank, and 8. And one number I feel in this will be divisible by 11. I think so I would do the method 2.
Yep. And easier.
I would do the method 2 that will help us to, so here, 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 okay? So I take 0, 7, 8, right? And then I use the color pencil for another one, 5, 3, and the box. Can anybody tell me 0 plus 7 plus 8 is equal how many? 0 plus 7 plus 8, how many?
15.
15. Very good. Okay. Then I have 5, 3, and box, which is 8 and box. Are you with me for this?
Mhm.
So I take 8 plus a box,
Mhm.
subtract 15. Then you want to tell me what number I fill in would be divisible by 11.
Mhm.
If I make this as a 0, right? And what number I have to fill in this?
7.
7. And that means that kind of solve for x. Does that make sense to you for the problem, something like this?
Mhm.
All right. If this is good for you, okay. How about I do it one more time, okay? In order to find out the number for this one, right? So I take R and even, so therefore we have 0 plus 7 plus 8, which is equal 15 for here, right? And we take a 5 plus 3 plus a box, which is equal A plus a box, right? So A plus a box, subtract 15 is equal 0. So therefore, a box has to be digit 7. So if I fill in 7, should be okay to solve for this problem. Does that make sense to you?
Yeah, that's a cool one.
Yes.
All right, makes sense to you. You do this one, okay? Tell me what's the number you fill in this will be divisible by 11.
Okay. Mhm.
Use the method 2 is much easier to solve for a problem like this. What you got?
No, I missed.
Did you get a 7?
I'm still trying. Let's stop. 6, 7, 8.
All right, let's check your answer on the board here. You have 2 plus 4 plus 2, which is
6. Oh, sorry, 8.
2 plus 4 plus 2, which is equal 8. Did you get 8 for this one? Yes or no?
Yes.
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 And then here we have 5 plus 7 plus a box. We don't know, right?
Mhm.
So that's the number we have to figure out. So we have 12 plus a box,
Mhm.
right? So now we take a 12 plus a box, subtract 8, right? And then if this is number, you can find it out what's the number. Is it divisible by 11, right? So therefore, okay, we have subtract x, so we have actually we have 4 plus this, or either what about if it did not 0, what about if we can either have a 0, we have either have 11, right? Now if this is a 11, because of 0, we try 0, probably 0 is we can get negative number, but we don't want a negative number. What about 11? If I want equal 11,
Oh, plus 11? So that's 22 minus 8.
yeah. So if this is 11, so
Then
the
we-
box has to be how many? Did you get 7?
And so that's what can I use?
So you feel in 7 is divisible by 11. Does that make sense to you for this problem? So either you want to find out here the answer will be equal 0 or 11 or 22, something number is 11, divisible. So it should be, if this is divisible by 11, then therefore, the number you fill in divisible by 11, so therefore it would be divisible by 11 for this number. All right, so we are here for today. If you have any questions you want to ask me, you can stay here, ask me. Otherwise, I think so. We are here for today. Okay. And then again, next time we will not have a meeting. We will have a test. Okay. And then the test would be available in the morning. Next Wednesday morning would be open, just like we did for your last, post test. Okay.
So we don't come on Teams, we just do the test?
Yeah, we just do the test. We just do the test for next time. And the next time, next Wednesday morning should be already available for you to do the test. You can find your convenience time to do it. All right. See you next time. Bye-bye. Have a good night.
Thank you. Bye-bye.
Thank you.
Bye-bye.
Good night.
The test is going to be on D2L like the problem sets were.
Yep.
I want those chair tops. I want to get up those chair tops. Give me those chair tops.
Then go eat a nugget.